Good morning. Thank you, Tanya, for the introductions. So what we will talk today at about 20 minutes, and we will provide enough time for questions at the end, is to showcase an open and integrated solution for hardware and software to implement artificial intelligence applications, leveraging products, as Tanya mentioned, from both AAEON and Eurotech. So for people that don't know much about Eurotech, I will just take 1 minute to go briefly into the history of the company to better understand the areas of expertise and the product offering. So we started more than 25 years ago, and we specialized in the design and development of industrial grade embedded modules, boards, and systems. What we figured out very soon at about, and I hope you can see my cursor here, but about this time when actually the company went public, that one of the key features to have these solutions, including all these boards and systems, work efficiently, was develop some communication software that could communicate among different computers and boards in a reliable, efficient, and secure way. There was nothing really there at that time. So you probably know the MQTT protocol. It was developed about 15 years ago in a collaboration between Eurotech and IBM. And now we are also proud to say that this MQTT protocol is really the de facto standard for communication between the edge and different cloud providers. Later on, and you see here in 2012, both Eurotech and IBM decided to donate the MQTT protocol, and now is both an ISO and an OASIS standard for everybody to use. An important other point is the launch in 2010 of the Everyware IoT platform. So it's a combination of hardware and software for IoT solutions. So that was almost 10 years ago. And more recently, we donated again, not only the MQTT protocol, but the entire software stack to open source, to the Eclipse IoT working group. And we will see the details in a minute. Okay, Eurotech has a global footprint. You see, I'm here talking to you from Boston. We have offices in Japan, several in Europe, and several in the United States. And this is the core part of the presentation today. So I will say, why AAEON and Eurotech together? Well, for two main reasons. We know that from the experience that we gain from all the IoT solutions that we develop with our customers, that an IoT solution really involves different hardware and software parts from, for example, different sensors, different gateways, several legacy systems, including hardware that has already been deployed and must be part of the solution, different cloud providers, for example, that should be an open and integrated and should work seamlessly together. So we have two examples here that are very interesting. We have an app automation IoT gateway from AAEON, and what Eurotech provided is the software that runs inside the gateway. And this is on the left-hand side of the screen. On the right-hand side of the screen, we have something exactly the opposite. We have a Eurotech gateway, ruggedized gateway, that is powered by the AI Core X module from AAEON. Okay, so what are we doing in here? Let us start giving a brief overview of the important part of the topic today, which is artificial intelligence at the edge. So yeah, we are both seeing hardware at the edge, but the core part of the presentation is this AI Core X module that we integrated in our gateways. So you guys probably already know because it's a quite successful module. The app AI Core X is a dedicated neural network and computer vision accelerator. So it's a computer board, as you can see in this image, and I can see in here. The form factor, it's a mini PCIe, and it uses, here in the middle, the Movidius Myriad X vision processing unit. And this is the core of the capability of a neural network in vision that we included in our gateways. This component, this computer board, is part of the UP family from AAEON, and is currently really the only AI module powered by the Myriad X from Intel available to purchase today. So what we will do in this presentation is talk first about the partnership with AAEON for the left-hand side. So basically why we are using the software in our gateways and in AAEON gateways. What is the advantage of doing that? And the second part is how we empower these gateways with an additional neural network accelerator capability in order to develop artificial intelligence applications. And here we see the entire picture. Here is what the ESF Everywhere software framework, what it really is, and we will have a couple of additional slides for that, is the software that runs at the edge. We call it Everywhere Software Framework. It's an edge framework. It's a framework that allows connectivity from the gateway to all the field devices and sensors, and then connects on the other side to different cloud providers. Could be the cloud provider that we have, which is called Everywhere Cloud, or could be any other Microsoft Azure, Amazon, IBM IoT Watson, and so on. So it's fundamental is that an IoT solution has to be open and integrated. So you can use different software, you can connect to different clouds, you can use different hardware based on the capabilities and requirements that you have. And this is just one detailed slides about the software that is running at the edge, that is running in the gateways. And it has three major things here divided from bottom to top. First of all, it provides connectivity to the field devices. So it's really complicated when you connect to different industrial protocols. Here you see the S7 for Siemens PLCs, programmable logic controllers, Modbus, OPC UA. So something that simplifies and creates an abstraction from all the different sensors and vendor sensors and devices and protocols that you have over there. And also a way to abstract and just gather simply, without writing code, data from your serial lines, the Bluetooth and the different wireless connectivity that you have at your edge, and USB, and also signals from the GPS and GPIOs and other digital input-output lines that you have connected to your gateway. So this is basically what is happening from the gateway southbound. So being able to read this data, interface with this protocol in an easy way. On the top, on the very top and here, this environment at the edge should be able also to connect to different clouds. So not only the Everywhere Cloud from Eurotech that has some additional capabilities, but as I mentioned, you know, to Azure, to Amazon, to the Eclipse, and many other clouds that are available there. Okay, and this is the northbound communication. But at the core of what the gateway should do is being able to run applications. And this is really the most important part of our presentation today. So when you use this ESF framework, this edge framework that Eurotech provides, you are able to write applications without using code, really. You have this data flow programming model in which you can drag and drop components, wire them together, and do very important things that like data collection, data consolidation, filtering, and all the other additional typical logic that are associated to an edge device. Okay. At the cloud level, not only we have multiple connections, but also the entire management, remote management, or not only of the devices, of the physical devices, so we can see what is connected, what is disconnected, what is the status of these devices, but also all the status of the connected devices. And this is what is normally introduced as the digital twin. So a digital representation all the way up to the cloud of what is happening in the field. Okay, you have a sensor that is represented as a digital twin. You have an entire Modbus connected PLC. You can see at the cloud exactly what is happening at the edge. And this is what is happening in the software part of the gateway. Let us see from the hardware part. Okay, so we mentioned at the beginning that we are leveraging the AAEON App AI Core X module, and we are supporting it in several of the gateways in Eurotech portfolio. You see here that starting from bottom to top, you have different gateways that vary in the level of ruggedization. The bottom one, the gray with the blue label, it's an industrial gateway. It has the Intel Atom, and it can host up to 4 cores inside. Then going up to the ruggedization level, you see the ball gate that is already certified for railway, both railway and mining application, still has the Atom processor up to quad core, all the way up to what we call it an edge server, a more sophisticated and powerful in terms of the characteristic CPU and memory that has different models that go from the Intel Core I all the way to the quad-core Xeon D, so very powerful machines. But the important thing is that adding the App AI Core X module in these gateways open up an entire universe of applications at the edge for artificial intelligence. And let us bring one as an example and show you what we did actually in a real world application. So we took our Ball Code 3017, that is the model name of this edge server. And this is what we can find inside. Obviously, I already mentioned the Xeon processor as a traditional CPU, augmented by the AI Core X module that has the Movidius Myriad X. It runs on Ubuntu, and we used, in order to write the artificial intelligence application, we used the OpenVINO toolkit. So for you guys that don't know that, it's, well, vino is not really, you know what in Italian means, it means wine, but it's really an open visual inference and neural network optimization toolkit. And it's a toolkit to develop application and solution that emulate human vision. And what it does, it supports the configuration and training of CNN, of convolutional neural networks, and supports the execution of these networks and these workloads across different Intel hardware, in this case, the Myriad X, maximizing the performance of the application. It's a toolkit, so you can write your application in different languages, in either C++ or Python. And this is what we did in collaboration with AAEON. So we opened, obviously, our Ball Code 3017. So there are 2 parts that are important inside. Obviously, the traditional server processor, that is the Intel Xeon D, but also we added the App AI Core X board inside. The interesting thing is that, as you probably you don't see very easily, but this server, as all the gateways from Eurotech, are fanless, right? They need to be certified for extended temperature ranges, vibrations, and as we said, they can be used in automotive and train, so there is also vibration involved. So one of the characteristics is minimize or completely get rid of any moving mechanical parts. And this is the case of the ball code 3017. So there is no fan, it's a completely fanless. And we have a very interesting and innovative way of dealing with the thermal dissipation of this, because as I mentioned, it can have all up to quad core of the Xeon D. And we are also able to add additional hardware acceleration assembling with the UP AI Core X. And this is an application that has been presented several times. What we did is connected to the ball core a camera, developed an application using OpenVINO that does the recognition of the face, and an additional application that actually sees whether a user, a human being, is actually holding a telephone in their hands. And when that visual pattern with the neural network is actually recognized, you see the result in the second window on the right, and it says, stop looking at your phone. So obviously, this is an application that will have wonderful value in the automotive industry, in which we know in every different state regarding of culture, now we know that people get very distracted using phones in their car. So this could be one way to help drivers monitor their behavior and say, well, you shouldn't use your phone while driving. And I remind you that this was developed with all the hardware we mentioned, and with the development of the application on top of OpenVINO. Obviously, the entire recognition and level of recognizing the usage of a phone is in real time. So there is no, there is a neglectable time between the recognition of the face and the phone, and seeing the threshold of actually recognizing that somebody, a driver, is using it. In one last slide, because we talked about the integration of all this, and I talked about the Everyware software framework. So yes, you see here, this is the complete software stack that is usually present in a gateway. Here you see two Eurotech gateway, but I could have put also the AAEON gateway, because it has, as we've seen at the beginning, the same software stack all the way up to ESF. But the interesting thing is that these applications, these environments at the edge, they need to be open, and we can integrate the different applications. So you see, for example, that ESF, it's sitting on top of Java and on top of Linux. And you can write application here in wires, right? And wires is what I mentioned at the beginning, is that way of dragging and dropping components without actually writing any code. But also you can have other applications here that are sitting on Java, you can develop on Java. Or you can have other toolkits that are not using Java. They're using, in this case, the OpenVINO toolkit. But the interesting thing is that if the environment, both from the hardware and especially from the software perspective, is open and integratable, you can have these applications coexisting with all the different software stack. Why is that? Well, it's important because, yes, OpenVINO, together with the acceleration from AAEON, from the AI Core X board, does the acceleration of the vision part of the recognition of the face and the cell phone. But you most probably will need acquiring other data. For example, the speed of the car, right? So if the car is idle, is sitting in a parking lot, obviously you will not need to do that. So you need to recognize sensors for the speed and many other sensors that could be involved in having a more intelligent decision whether the driver is distracted or not. And this is integrating the environment at the edge with all the sensors and additional devices, like, for example, different parts of the car in this case. But also being able to communicate to the cloud. That's another part that is essential, that works together with an artificial intelligence application at the edge. And here's some context of my company, and that really was the entire presentation. Thank you very much. And now we have some time for open questions.